My name is Rob Crowley, and we're going to be covering quite a bit this morning. So first off, how many people are using GraphQL in production in the room? A few hands? Cool. Maybe other people who've just had a play? Nice. What we'll do for the first 15 or 20 minutes of this talk is just get a rough grounding in the basics of GraphQL. From there, what we're going to do is move beyond request-response type architectures, then move to push-based. So how do we get real-time data interactions with the server and the client? What we're going to do then is really a tale of two cities. We're going to see what it actually takes to do that on the server side and then on the client as well. And finally, with a lot of these data-intensive systems, it's how do we actually tune them? How do we make them performant? So we'll then look at a number of tips and tricks to actually get the most out of these when you go to implement them as well. So a little bit about myself. My name is Rob Crowley. I am a principal consultant at Readify. Previous to that, I was the tech lead for APIs and authentication at Bank West for a number of years. So the vast amount of my experience is around distributed systems design and architecture. And to be honest, I'm a bit of an architecture tragic. I'm also the co-organizer of DDD Perth, which is Western Australia's largest IT conference, and I'm also available on the socials on the right. Confession, I absolutely love GraphQL, but I also love REST, so this isn't going to be a talk where I'm bagging out REST. We're going to try to be quite objective, and as we come across certain scenarios, we're actually going to highlight, well, maybe some things are actually easier in a REST-based architecture, and then some of the things that we have to apply to GraphQL to get the same sort of characteristics. So also love REST, and I'm absolutely fine with that. So when we build APIs today, what we're really building is products for other developers. So developers being our consumers. And developing APIs today is quite a complicated landscape. We have many different types of clients that interact with our data. We've got voice, which is just emerging, 0D interfaces. We have 1D interfaces with chat and text. We have traditional 2D interfaces with web, and we also have emerging AR and VR, HoloLens apps as well. And each one of these clients demands very different amounts of data from our systems at different times and in different manners. So the challenge for us of building a compelling API experience today is far more complicated than even a couple of years ago. And so the question arises, how can we efficiently send the data that each one of these clients needs? So do we have single-purpose endpoints like what we might do in REST and just every client gets the same data? Well, that could be incredibly wasteful. So what we can do from there is we're always trading off. So do we send too much data to the client? Well, that's wasteful again. Or do we send too little and then force them to make repeated calls? So typically like a hypermedia-driven flow with a REST API. That's an example of underfetching. But what we really want to do is not just efficiently send the data to the client. We want to send exactly the data that each client needs in one round trip to the server. That's what success looks like in this. And what we're going to do is we're going to take a quick look at GraphQL in action now. And I don't think there's any better way to kind of get an understanding of how it hangs together than just to start issuing a few queries to it. So what I've just opened up here is GraphQL Playground. So if anyone's played with Graphical, it's a very similar idea. So this is just an updated version from Prisma, which has support for some of the real-time capabilities, which we'll look at as well. So you can really think of this as an IDE for GraphQL, where you can start composing queries. So what we're going to start on the left-hand side is a very, very simple query, where we're just going to return a little bit of data about a film. And our domain today is pretty typical. So we've got to have films, we've got to have actors, and actors that appear in certain films as well. But what we've just got to say here is I'm requesting a film with ID of 2, the title, and the description. And that's pretty darn basic right now, but you can already see some sort of flavor for it. So in GraphQL, what we have denoted between these curly brackets is called a selection set. And then each one of the items within it are called a field. And you'll also see that the shape of the data which I get on the right-hand side mirrors that of the query on the left. And of course, you're in the room thinking, I could just do that with a RESTful API already. So let's keep digging. So right now, we're then going to say, Okay, well, let me look at the cast for this. So I want to see a little bit more about the actors that have appeared in this movie. And from here we can say, okay, for this particular actor, get me the actor's name. So right now I could still see in one query, I can get not only top-level details about the film, but I could start getting a list of all the actors within that. And likewise, I might say from there is, I'd actually like to know what part that actor played. So again, I can just go in and just arbitrarily build up these queries on the left. But as I go through as well, I might then say, well, for each one of these actors, maybe I want to get all of the movies that they in turn appeared in. So in this case, now I've just arbitrarily built that. So now I'm having not only the film details, but for each one of the actors that appeared as that, the role they were cast at, and any other films that they were casted or appeared in as well. So what you can see is we have a complete inversion of responsibility here. With a RESTful API, we declare endpoints that define how our consumers interact with our APIs. With GraphQL, all of that power goes to the client, so the consumer defines the shape of the data that it requires, and then the server infers that and then queries that data. But you'll also see as I go through that Graphical or Playground seems to know what a valid field is. So I'm not just typing randomly, there's this type ahead. So some people in the room now are probably starting to think there's some sort of schema involved here. It's defined, strongly typed, and you're absolutely right. That's the fundamental, or one of the fundamental building blocks of GraphQL. And likewise, what we can do from here is we can actually do a little bit more complex queries as well. So in this particular case, here's an example of a search, whereby I'm not just looking for one particular type. I'm actually then saying, if it's a film, return this sort of data. If it's a genre, return this type of data. So again, we're using this concept here, denoted by the 3 dots. Looks quite like a spread in JavaScript. It's exactly the same concept. But what we're going to do here is when we execute this query, we're then seeing that I get different return sets based on each one of the components on the right. So this is using a feature called unions in GraphQL. It's not vital to get that concept, but what you can start seeing up now is this is an incredibly rich and powerful query language that you can start doing really amazing things to pull out the relevant bits of data for each client experience. So there is a schema. The fundamental building block of a GraphQL API are its types. And this is an example type from our domain. And this is defined in a notation called SDL, or Schema Definition Language. And what you can see from here is that there's, again, a number of properties on it. There's an ID, and it has type ID, so an opaque identifier, typically rendered as a string. And it has an exclamation mark on the right-hand side. That basically means it's required or non-nullable, such that if the client requests this field, it will either be guaranteed to have a value, or the server will throw an error. So you can make an assumption that as part of the contract, you will always get a value or an error. The next field down is type string. So that's another primitive in GraphQL. There's also floats, booleans, a number of others. You can also create your own scalar types if you wanted as well. So you might have an example of a date. You might want to represent that as an ISO 8601 date. So absolutely, you can take that string and then apply those formatting rules to it. A little bit more interesting is this appeared in. So the square brackets denote a collection, but this is another custom object within our schema or our domain. So what you can now see is this is how we actually link our types together. So as I could navigate in the query and I could go from this is the film, then go down to the actors, this is how we define it in our schema. And then again, net worth, that's just an example of another custom object within there. But again, it doesn't have an exclamation mark on the right-hand side, so the client may get a value or may get a null. And the convention in GraphQL, if you either don't have permission to see a field, or if there's not a value, you will get a null. And then against each one of these fields, we then associate an arbitrary piece of code called a resolver. So up at the root level of the query, which you would have seen in the example before, we have this piece of code, and it's going to take in a number of parameters. In this case, there's a root value, there's any arguments that get passed into it, there's context objects, so anything you want associated with the pipeline of that request. And then there's also a fourth argument, which we'll cover a little bit later for some other scenarios as well. But all we're doing here is GraphQL is absolutely agnostic of the data source. I don't want to move. So what we can do here is it could be a database, it could be another service, it could be an MQP topic, it could be anything. GraphQL does not care. And then against each field on those types, we then associate another resolver. So in this particular case, we're going to say the title field on the film object, basically it's going to take a film object in, and it's just going to extract that title field and then pass it back. So what we're going to look at now, I know it's first thing on a Friday, so I do apologize, but we're going to cover the absolute minimum we need to know to land in a vocabulary that's suitable for kind of discussing some of the concepts in GraphQL. So first of all, we have this concept of a tree. And the eagle-eyed among you might say that really represents the query that we had on the left-hand side. So you can really think of a query as a tree structure where each of the nodes in the field will either resolve to another type or be a leaf node and respond to a primitive data type. And we know the query is complete when each one of the leaf nodes are pointing at a basic field, for instance, like title in film. And what that query is, it then projects onto a portion of our object graph. So we really think in GraphQL to move away from thinking in terms of like relations that we would in a database, but rather project and view our data as a set of interrelated nodes or graph. And what we can actually see from here in this example is we have a couple of types of objects here. We have films and actors. And for any item that appears within a graph, this is referred to as a node. And then the relationship between two nodes is called an edge. And you might have seen in the queries that I was typing, it had edges and nodes in there, and that's where the language came from. And I'll explain why we model our schemas like that in a moment. And then for each one of the edges between them, we can then associate particular information. So in this case, we can see each one of the films is connected by a franchise relation. And again, if you've been playing with GraphQL for some time, you might have also heard the word connection. And a connection is a group of edges related to a certain piece of metadata. So for instance, for a film franchise connection for this film would return all of these edges to its connected neighbors. Okay, so let's see how that will actually work in practice. So once GraphQL receives a query from the client, how do we actually start processing it on the server? So first off, we will have a query resolver. So this will take the ID of 2, and it will then execute any arbitrary piece of code that we define to return that object. What it's then going to do is it's going to pass the result of that off to the resolvers on the film object. So the query will know how to return or how to retrieve a film from the underlying data store, but not how to format it back to the client. So what it then does is it calls another resolver. And this resolver will then return title, but then also characters. And again, that resolver will then return the characters for that associated with that film. But again, it doesn't know how to retrieve names and actors. So again, that resolver will call the resolvers on the characters object and return name and actors. Absolutely the same when it comes down to the actors object, which will then return the name property. And at this point, we have traversed down to the last leaf node in our query, such that we know we are complete and we can package up the responses, send it to the server. So what I hope you can see now is that there's absolutely no magic with GraphQL at all. Even though it's incredibly powerful and flexible for the client, it actually gets executed in quite a simple manner on the server. So wrapping up that, GraphQL, query language for your API, it allows us to craft strongly typed queries. So we actually know at compile time whether a query is valid or not, so you won't have any mismatches at runtime. The massively powerful thing with it, particularly if you have to support multiple clients with very different data needs, is that it facilitates retrieving exactly the data you require. And it also has powerful features such as introspection, so you can actually query the schema itself to see what a valid type is. And we've already seen an example of that within graphical/playground, where we could actually retrieve the valid fields for a type. So this is incredibly powerful as well, because it opens up a whole host of possibilities around, well, if you already know the shape of your query, why can't you code generate a view model for that as well? So there's a lot of really powerful things. So on the whole, I do think it's pretty cool. But request response only gets us so far. So why do we need real time? In a lot of our applications, we simply send a request, wait for the response. But think about what we do today. We have a whole bunch of real-world examples as well. So we have 1D interfaces, so chatbots as well. That's inherently bidirectional. We want to send data, but we want to retrieve data. We want it to feel live. We want it to feel snappy. We want to have push notifications and a whole bunch of other dynamic data coming through. So really, a lot of the experiences that we build today, our customers already expect real-time interactions with the server. And we need to catch up with how we're building our API. So typically, we might have done that through Signal before, or another approach. And again, in the banking scenario, so I'm with Combank, so whenever my pay goes into my account, I get this wonderful push notification to say, I'm now rich again, comparatively, and I can go spending. That's absolutely amazing. So again, I don't have to request that data. It's just, again, that value add that the server can then say, here's this information that's valid. So again, if you have other examples like stock market trackers as well, you're not going to have a certain example there where you query it and the page is stale. Again, any updates, you have a push back to the client. So what options or approaches do we have for supporting real-time experiences in GraphQL? Well, a pretty much mainstay to date across any of these experiences is polling. Simply, we will just have the client at set intervals ask the server the same question, ask the server the same question. And this is actually not a bad approach in a couple of circumstances. So if the data refresh rate is known, insofar as an example from a banking domain, the product rates will get updated once per day. So that's absolutely fine. Literally from there, call it once per day, call it the same time tomorrow, that's absolutely fine. If that cadence was then once every hour, that's still fine because it's known. If you don't know it or the update rate is non-deterministic, then you have to balance freshness with chattiness. So are you willing for the data to be a little bit stale, or do you risk sending quite a lot of traffic across the network? Another approach that's been talked about quite a bit in the GraphQL space is that of live queries. So a live query, you can really think of it as infinitely fast polling from the client. So you would send a query to the server, and if anything happens to any of the fields that you requested, you just want to get an updated version. And what we could do for that is the client can denote that they want a live query by putting on this declarative marker on the right-hand side. But while it sounds like a very attractive option, it's awesome for consumers. So basically from there, you're just, anything changes, send the data back to us. It is absolutely a nightmare for the provider side, though, to try to scale this and build it effectively. Any of the resolvers change, trying to identify that particular scenario and then push data back to the client. So there's really only a few companies that I'm aware of who've actually now built live queries. So Facebook is obviously one, and a number of others as well. But this is not actually part of the formal spec as yet. You don't get a lot of support for this out of the box. So over the last year, the community has mainly landed on a different approach, and that's called subscriptions. So subscriptions are based on events. So whereas with request response, so in a query like we saw earlier, there was one query and you would get one response. What we're doing with a subscription is registering our interest in 0 or more occurrences of some event at some point in the future. So we don't get a response back instantly, but we will get it back potentially at some point in the future. So to be clear, these are really powerful. They're not a replacement for queries, but as you'll see, when used appropriately, they can really give that liveness to the interactions with our users. But there's actually quite a bit of plumbing that needs to go into supporting these. So on the left-hand side, we would have the typical pipeline we would have for mutations and queries. So request comes in, it will then go down to your GraphQL server, which will then delegate through its resolvers down to a business domain. So that can either run in process or cross process. GraphQL doesn't care. But of course, now if we're going to have persistent connections with the client, we have to introduce state. And typically in GraphQL, this is done through WebSockets. So that's the bidirectional transport. What we also introduce is this subscription manager that will then hold all of the subscriptions that have been requested by the clients. The subscription manager will also interrogate the subscription type on each one of the GraphQL schemas, and then keep a mapping between the two. So what will then happen is your business domain can raise an event. So that might be an example of payment received or any other business domain event that's typical in the area in which you work. And then the subscription manager will listen for an occurrence of that. Based on that subscription, then call into GraphQL to retrieve the requested data and then stream that back to the client. So let's look at an example. So we might have a user, and the user will connect to the subscriptions endpoint on the GraphQL API. So you'll notice here that this is WS as the protocol. So WebSockets, of course, you can use WSS as well if you just wanted it authenticated in production. And that's the stateful connection between the user and the server. So what they can then do is subscribe to an advertised event. So in this particular case, the server exposes a review added subscription. And the client then for the structure says, when this particular event happens, I want to retrieve the review. And for that review, I want to retrieve the rating item. But I also want to grab the film title as well. And then what can happen is another user can come into the system and add that particular review. And what will then happen, that's the event that's being fired. And then you will see that the server will then push that notification directly back to the client. The client didn't have to do anything else. The data just gets pushed back to it. So let's take a quick look at that. So again, I'm getting type ahead here. So we're going to say review added. And in this particular case, I'll grab the review. And in this particular case, again, I just want the content of that review. And this time when I click play, what I'm having is we're at the point now where the WebSocket connection is live between these two servers. Going back over to adding a review then, what we can now see is the first one of those events has been pushed and appears in the stream on the right-hand side. And you can see down the end that we're still listening. So if we were then to create additional reviews, that data will keep being pushed as a stream back to the client. The most powerful thing about GraphQL subscriptions is the fact that they provide a consistent interface. Typically with event-driven systems, you need to comply with the shape of the event itself. With GraphQL, each client can still describe the shape of the data they want to receive when an occurrence of that event happens. That is incredibly powerful. And I have to confess, the first time I saw this, I was like, that's a massive game changer. Because what that allows me to do is I can have my initial query to fill up my page with the shape of data that I want. And then what I can do is I can then subscribe for updates to that in the same shape, such that when that data comes through, I can just merge it directly onto that page and refresh it. I don't have to do any massaging or translation from that domain event back into the view model to display on my client. Okay, so real-time GraphQL. you have a number of options. Realistically, today we're looking at either polling or subscriptions. Choose polling if you know the rate at which your data will refresh. You could avoid a lot of the additional bidirectional plumbing you need to support subscriptions. If you do need that liveness through events or have a more ad hoc data refresh scenario, then subscriptions are massively powerful. Best thing about them, the consistent interface across push and pull. It's incredibly powerful. GraphQL allows you to support both paradigms seamlessly through one standard interface. So again, if you have any teams at work as well, you don't have to support or learn another approach for dealing with this. So it simplifies the landscape quite a bit. And again, massively powerful when used appropriately. So the first thing I would always look at is, can I just make this a query? Then will polling be suitable for what I need? If both of those are no, then you start looking at subscriptions. OK, so far we've been really looking at GraphQL sort of baseline and how we actually look at it on the server and support some of these pieces of behavior. What we'll now look at is a couple of the options that we have for the client-side part of this story. And again, coming back to the fact that APIs are really products for other developers. We build them, and we want to make sure that the consumption of that is as seamless as possible. And there's this rule of threes that I really like about APIs. And it's the 3 seconds on the left is a developer should be able to understand the purpose of your API in about 3 seconds. They should be able to gain access to your API within 30 seconds. And they should be able to make a call to that API within 3 minutes. That's what you're really looking at as an excellent onboarding experience for your API. So if you're working internally at your organization and with internal developers, maybe you have a bit of a captive audience. But again, if you're putting an API product out there and you're looking for people to consume your service, then focusing on the developer experience is absolutely key. And developer experience really comprises 2 main parts. First of all, you have documentation. So again, this attests to can actually people understand what the purpose of your API is in that 3 seconds. And GraphQL has a very powerful story around documentation. Because you have a fully formed schema, you can do really nice documentation on the back of that. And you actually get a huge amount of this out of the box as well. So if you go to GitHub's V4 API, which is based on GraphQL as well, you can actually have the documentation and explore it through Graphical and Playground as well. So you get this IDE where you can start interacting with the API very seamlessly. And the other part of developer experience is then the SDK. So if you're building an API for consumed by other teams, you can often know a lot of your time is actually spent on building these system development kits. So again, if you support clients that use Java, you'll have one that runs in the JVM. If you have clients that use .NET, again, you'll have one from there, and maybe many other languages as well. By moving to GraphQL, you'll notice that you get all of this work done for you. There's all of these clients available out of the box. So again, with GitHub's example, with V3, they had client libraries for many, many different languages. V4, they don't. They don't need to. That work is done by working off a standard interface with GraphQL. There is a huge community around that will build these clients for you. So again, another massive win of GraphQL is most of this equation is solved for you. Documentation, you get a massive head start on. And there's GraphQL libraries for practically every language out there now. So most of the clients that I'll be looking at today are based on JavaScript. So the reference implementation of GraphQL is based on JavaScript as well. There are implementations across many different languages as well. I'll show you a link on the reference slide at the end, which will then point to where you can find what the appropriate implementation is for you. But in the JavaScript space, literally the simplest client you could possibly imagine is GraphQL request. And this is actually great for scripting. And all we do is, again, import it, write our query, and then it's a one-liner to send it to the server. So if you only need to do really basic calls from a client, then start as simply as you can. So if that's the simple end, Relay from Facebook is absolutely at the other end of the continuum. So Relay is Facebook's solution for building data-driven applications with GraphQL. But it is massively complicated. So the GraphQL spec is about this big, the Relay spec is about this big. So my advice really from there is, unless performance is absolutely key to your requirements, like it's a fundamental differentiator for the apps that you're building, I really can't see the payoff for Relay for most teams. It has all of this pre-compilation phase whereby it will then do fragment aggregation as well. So it's really about optimizing the network portion, which again makes a lot of sense for Facebook with massive geographically dispersed users and huge volumes of data. So by all means, be aware of it, but I would be surprised if that would be your default or best choice. We do need to be aware of it though. So if you're building a public GraphQL API, decide early on whether you're going to support Relay clients, because Relay is incredibly opinionated and it will force a certain shape on your schema. So again, any connection to a list of other objects can't be modeled as just a simple array. You have to build these connection objects. And they're actually quite complicated as well. So it forces you to model edges and nodes and page information, and then explicitly map each edge as well. So there's actually quite a lot of overhead or complexity that you need to introduce into your schema. But Relay only wants to do pagination with a cursor-based model using connections, so therefore you have to support it. So the advice is from there, if you're building a public GraphQL API to be consumed by other people, think strongly about supporting Relay. Simply otherwise that you're making choices or implied choices on your users that they then can't use that library. If it's for internal use within your company itself, then measure for yourself. In the example code that I've used here, I have used connections, and I'll share the link for that at the end of the application. But then you can see some of the helper methods that you get from GraphQL Relay as well to help you build some of the connection objects at the background as well. But you'll also see that there's quite a lot of code still to make that work. In the JavaScript space, my personal favorite is the Apollo client. So again, massively featureful, great feature set, really flexible, not tied to React. It also supports Vue, Ember, any number of public libraries, as well as community driven, which I absolutely love. So what we can look at now is a quick demo app that actually, instead of using Playground, will actually then have a simple React app that will allow us to do similar functionalities to the demo that we saw previously. Okay, so first of all, I will apologize for the horrendous color choices, but there we go. Is that still clear for everyone at the back? Cool. So the first thing that we're actually going to do is we're going to log in. So this is still going to our GraphQL API. So that's sending a mutation. So what I've done here is send that to the server, and then it's going to return with an access token that I've stored in session storage. And then it allows us to query for, again, any directors, films, actors, characters that match that particular scenario. So in this case, it's found for the letter A movie called Raging Bull. So again, quite a classic. So again, clicking on this, we can now get the list of reviews for this particular movie. But what I've done on this page as well is I've also set up a subscription. So this is now listening for any new reviews that get added to this film. So then going back into Playground, I can do the same thing as I did before and create a new subscription from there. And instantly the client has been pushed with an update here. But we're also seeing that the data has appeared in this query here. So I actually have two subscriptions on this page. I have a subscriptions object itself, which you can see in the code here, which again has a particular query. So quite simple. So it just says for any time we have this subscription, I want to retrieve the review and some data about the movie itself. And then going down, we'll see the query component itself. So Apollo client, or Apollo React, with the React specific part, then exposes a number of these components. So one for subscriptions, one for mutations, and one for queries. And these follow the render prop pattern. So again, for each one of these queries, we will then have the section of data. So in this case, I'm getting data and loading as props passed into my method. And all I'm doing from there is issuing a div with that data. What I'm also saying is I'm resubscribing to future occurrences of that event as well. So while I showed you render props there, and I don't want to kill you with code, this will all be available afterwards so you can drill through it in your own time and work through these demos as well. But you can also use higher order components if you wanted as well. So as with Apollo v1, it's shipped with a GraphQL hook, so you can absolutely still use that for composing functionality if you choose as well. As of release 2.0, they've really been pushing the render prop queries, mutations, and subscription components. But again, the choice is yours. So yeah, use both. OK, so performance. So you can obviously imagine if we have a lot of data flying back and forth between our systems, we can either build quite chatty or potentially do we have a lot of visibility in those, how those are performing in production. And also you want to know is how fast is fast enough. So one thing that you will also get out of the box with GraphQL is, with the Apollo server, is quite fine tracing along how long each resolver takes to execute, such that you can highlight performance bottlenecks within your system as well. But one of the gotchas with this is, with one response to the server, our response is constrained by the slowest resolver. So if I have one piece of data that takes a long time to retrieve, the entire response is delayed. Like, that doesn't sound that great. And in fact, in the REST space, with the advent of HTTP2, we can now have streams and server push. So what we can still do is have very fine-grained resources, but then push all of the related resources with that as well. And then we can have different cache volatilities for each one of those resources as well and cache appropriately. So again, we can decouple ourselves from the slowest piece of data. So how would we tackle that? So Apollo supports, in the alpha release now, a defer directive. So similar that we saw the live directive before for live queries, this defer directive allows us to annotate certain parts of our schema. And when we annotate it, what it's actually going to then be inferred is we're going to delay sending that response back on the initial response and then send a patch later. So we can do this either at the type level itself or at individual fields within that type. So again, let's see an example of how that might work. So what we have is the client will send an initial query to the server. And in this case, again, quite simple. We're retrieving the title and then back on the reviews. We're also retrieving then all the reviews for that and the content. So you would have seen in the previous example that we have a defer directive both at the review object itself, which again, using our graph nomenclature, is now a node in the query, and on the content field itself. So what the server will then do is send back an initial response without any of the deferred fields. So in this case, you can see that the entire edges for review connection is null. What the server will then do is process all of those other requests, and when the resolver has completed, push a patch using multi-part HTTP back to the client. So if your browser doesn't support reading streams, then it will fall back to just standard blocking response behavior for the query. But what we'll now see is the initial rating object has been resolved, but content is still null. And you'll see that this has a slightly different format to the previous response. What we have in the top section is the path. So how do we uniquely identify where in that response tree this data should go? And from here, we have a rating of 9. But again, content is still null because we also marked that as being deferred. So what we'll then have, what we'll see is that content has now been appended onto the path list, and we now have the content field. And then finally, when all the patches have been returned to the server, to the client, then we have all of the data. But this introduces an interesting little conundrum, because we just said earlier that if the field is either missing or you don't have access to it, you'll retrieve a null. But we're now using nulls for pending values as well. So is there ambiguity there? How will the client know, well, should I actually expect data, or is there just nothing there? So what we could also have is another prop that can get passed into our render prop function. And in this particular time, it's called loading state. And loading state is the same structure as the data tree. So what I can do here is I can query for loading state, check the review, and then check if the content exists for it. If it does, then if that resolves to true, then retrieve that particular content. So we know at that point that the patch has been received by the client. If it's not, then we say it's still review pending. So what we can now do is deterministically identify for each one of those deferred fields which ones will I receive a value for, or which ones are always going to be null. So that's a really powerful technique then, and quite simple, I think, as well. Another pretty cool feature that we can use as well is persisted queries. So another concern that you might have is that the client sends a lot of data to the server every time, like each one of these queries as well. And that can result in quite high traffic volumes. So, and then we could also say, well, what's the point of that? Can we do something a little bit better? With REST, I have this really nice little URL that can describe that, the canonical URL to that resource on the server. So what can we do about this? So again, in the GraphQL community, and we've actually then landed on this concept called persisted queries. And what we do from here is, this is an example of the config in the Apollo server, where we have this configure item about persisted queries. And what we introduce is another key value store, which will then, in this particular case, I've chosen Redis, but there's options for memcached as well. And again, we just link the two. So what will then happen in a scenario where the client wants to not send the entire query, but just send a hash of it. So again, this is a SHA-256 hash that it sends to the server. And it generates this hash based on the query contents itself, and it sends it to the server. What the server will then do is look at the key value store and say, does a query exist for this particular hash? This is an example of the very first time that a query has been introduced, and the key value store says, no, haven't seen it before. The server will respond with a validation error. At this point, the client will then send the hash, but also the body of the query itself. Server's going to execute that query. It's going to store the query for that hash, and then return the response to the client. So this is a flow that will ever only happen once for the first time you see that query. On subsequent run-throughs, what we'll see is the optimistic request again from the client goes straight to the server. This time, we actually retrieve the stored query for this. We execute it, and we pass it back directly to the client. So what you can see from here as well is, on the top here, I have an example of the initial request that the server would send. So again, on localhost 4000, within the extensions field of the query, and I'm asking for retrieve the query for this hash. And of course, what we see now is that the query doesn't exist yet. So I've got a persisted query not found. So in the example below, what I've actually done is included the body of the query as well. So in this case, it's just a really simple query, just retrieving the type names. But what I can do then is, once I actually persist this, once you go back now to the client up here, which is the exact same process as the Apollo client will use, what we're then seeing is that the query gets executed directly. So that's just a concrete example of showing if you unpick what the Apollo client code does, it's pretty much this. And there's benefits of doing this as well. So one of the things that always irked me about GraphQL is it treated HTTP as a dumb pipe. Everything was a post. So you didn't get any of the benefit of caching or all the other value that HTTP provides. And you could possibly argue that the more customized your queries get, the less value you will get from caching, full stop. But I think there's still, like a lot of improvements we can make there. So a really nice thing, now that we have a very simple structure anymore, a hashed query, we can now turn all of those posts to gets. So on the Apollo side, this logic is held within the Apollo linked persisted queries module. And again, quite simple to set up. So again, link is a structure within the Apollo stack. It's like a programmable network layer. And then you can chain multiple links together. So in this persisted query link, which is responsible for the same interaction that I just showed you with the API calls earlier. And then we just set the property of use get for hashed queries. And from then on out, all of our queries will then be sent as gets for the ones that have been persisted. Now we can start getting value from caching. So we have this @cache control directive, where in this case I can say store for 60 seconds. And again, I can do this either at the type level itself or any of the individual fields. So you probably get the initial feeling of persisted queries can help with just that initial traffic from the client to the server. But now you're seeing that, again, a lot of the investment that you might previously have made in proxy tools like Squid or Varnish suddenly start paying off again. But with great power comes great responsibility. So now that we've given all of our users this power to craft whatever queries we love and whatever queries they want, what happens if they do pathological queries, either malicious or, again, just queries that would be horrendously expensive to execute on the server? So you might notice that we can completely avoid this issue if we only use persisted queries, such that we will know at compile time all of the valid queries that could hit our server, and we could actually do performance analysis on it ahead of time. But again, that's quite restrictive, and if you've got to have public consumers of your GraphQL API, not really an option. So how can we protect our APIs from these queries? So we looked at the structure of a resolver previously, and we looked at the first 3 arguments, but there's also a 4th argument that gets passed into it called info. And this represents the abstract syntax tree for that particular query. So again, all of the fields that you're going to see. So again, in that example that we showed of like traversing out down through the nodes, you get that structure such that you can interrogate it. And that allows us to do a couple of things. So we might have one control based on purely the depth of the query. And there's a package for this as well called GraphQL depth limit. And what we can then say is, for this particular query, I can say only support queries that have a depth of, let's just say, 3. And then it will traverse through down to the query. So at this stage, we're at depth 0. Within that film object itself, we're at depth 1, down reviews depth 2, and then aggregate rating depth 3. So any other queries that are deeper than that, you would just say, no, reject them. And it's pretty brute force, but it can be effective. So I wouldn't start on day 1 with this. So put your queries in, and then see over time what the maximum depth of one of your queries is. Typically, the largest I've had is about 8 to 9 depth. So I set the depth at a max of 10. But you can see yourself that that will probably vary based on your domain and the complexity of the queries that you're crafting. A slightly more nuanced approach then is this concept of query cost analysis. And what this says is really based on that all fields don't have the same cost associated with them. In the same way that we might want to defer the slow to render fields, we might also say that, well, that's a more costly operation for the server. So again, we have a package called GraphQL cost analysis. And what that lets us do through another directive, associate certain complexity values with the fields. So in the same way as we're traversing down through that structure to execute the resolvers, what we could also do is traverse that tree and keep a running total of the cost of this. And then we could put an arbitrary value. Let's just say the max cost is 50. If you've worked out that it would cost more to resolve the query than that, then you just fail it up front. And this is incredibly flexible. So I've just sent a hard-coded value of 2 there. You can also define multiplicative values. So if it appears within a collection, you can then say that maybe each value is worth 2 times that, depending on the depth as well, if you get an exponential growth to your query. So you have a huge amount of flexibility there. So if you're doing building a production GraphQL API, I would strongly encourage you to look at both of these techniques and persisted queries if applicable as well for your use case. Okay, so main takeaways. GraphQL supports both synchronous reads and writes, but also real-time interactions through subscriptions. The magic of this is that it's entirely through one interface. So if you're working with your teams, you don't have to introduce a new set of techniques or a new technology to support those different scenarios, so you can integrate them seamlessly. With any of these things as well, we want to keep the surface area of our APIs tight. So if you can use features like persisted queries absolutely do it. It will not only give you a performance boom, but also tighten up some of the edge cases or performance cases you might see on the server as well. And Apollo Client, I'm convinced, is the best all-round client for most of the business applications that we'll write, and absolutely worth your attention. So, thanks a million. I really appreciate you making it out this morning. So, I'll put up a reference slide at the end. This is the demo app from the talk. I'll also tweet out my slides a little bit later this morning. But this covers both the GraphQL client, so it goes through subscriptions, mutations, so any of the functionality that you've seen before, and then also the server side as well. So we do have about 4 minutes for questions. So, hi. Yeah, it's a really good question. So an example of a mutation for anyone else here is this is an example of how I've done login in this app. So again, it's just a mutation, and it will take a login input object, which I pass then through query variables. And in this particular case, you'll see the password that's in the code anyway, but it's just NDC Conf in 2017. I use the same database from last year's presentation. I do know what year it is. And then that will get minted over on the right-hand side as an access token, which I then just pop in the authorization header. But the question was, so when you're doing mutations and you're not retrieving the full object structures that you would have from a query as well, how does that affect refetching? And yeah, you're absolutely right. Then you will have warnings throughout. If you look at the Apollo tooling, again, this is another piece that I would recommend everyone to look at if you're. So there's Apollo DevTools, and then you'll see down in the cache structure as well on console, you'll start seeing all of the objects that I have in the cache from here. But you will start seeing warnings then around refetching if those particular properties or titles, for any of those don't exist within those objects themselves as well. So a key structure from here as well is I always look to keep the shape consistent across those queries. And if you're doing multiple queries, return like an ID and the type name as well, such that you can differentiate within the cache itself. Hi.
Hey, how would you recommend defining a query that might have a recursive structure, like nested comments with replies or file structure?
Yeah, you can absolutely have. You can have a recursive structure, so like I've shown in that query as well, where you can go from actors to the films that they appeared in and then back to films as well. But because it's a tree structure, and we will always start at the root, and we only fan out, then you will never have a case where you get an infinite loop from there, because we're just parsing the tree straight down. But obviously from there, then it starts playing in with like the complexity of that and the amount of like recursive structures on the server side and the complexity of querying that data. One of the things that's a really powerful pattern for that is this concept of data loaders. So data loaders here are a library that you can download as well for it. But what they do is per request batching and caching. So if you looked at some of the queries that come through, even if I'm requesting the same object, let's just say actor with ID 1, and that appears multiple times without that graph, what we'll do is data loader will actually listen to all of the requests for that object, but not execute them directly, actually execute them on process.net tick. And then it will actually only send one query downstream, and then all subsequent calls will actually retrieve that same object from the data loader request cache. And then the trick with data loaders is I pass them in on that context parameter for each query, such that it then gets refreshed each request. So again, it's like per request batching and caching. But that helps a huge amount on reducing bandwidth or reducing calls downstream. Excellent. OK, last question.
How do you make sure on the server side that the GraphQL layer doesn't become too big when you're dealing with a lot of resources?
Excellent question. OK, so the trick with GraphQL is don't put business logic in GraphQL itself. So the resolver layer should be incredibly thin. So the resolver layer itself should just call down to another business logic layer, either in process. So I write a lot of NPM modules then as that business logic layer. So again, in this particular example, I've put them all together within the same solution, but I always look to build, so just in the case of film, like one access point to retrieve those data from any of the resolvers. So in this case, the only way that I can retrieve a film is through this one function. So that's where any of your business rules go. So for, let's just say you had a business rule that you can only return, you can only see your own record. So I think we have an example here. So if I wanted to retrieve a user object, basically the login has to match the login user as well, so you can only see your own record. So the trick is not putting that in the resolver layer at all. So that's the first step. But then what that allows you to do is use a feature called schema stitching. So what you can then do is have separate portions of your schema modeled as separate GraphQL servers, and then have a GraphQL gateway above that which will aggregate all of those disparate schema fragments and tie them together to one cohesive whole. So if you're actually querying it from the client perspective, it's invisible to you. But then you've moved away from having a centralized architecture to decentralized around particular functions. So again, at one of our clients that we were working at, we ended up splitting the schema across, Gary, is it like 5 or 6 different, so we had one about products, customers, yeah. And then we'll have the client, from the schema stitching perspective, then tie that together. The trick with that, though, is you can still do all of the linking between objects within the individual schema fragments themselves, the same as you would before. But you want to keep the amount of code to kind of glue separate fragments together pretty minimal. So you'll have to use to say, are these really tightly coupled? Like, do they live together? Do they change together? Probably stick that in the same schema fragment, because otherwise you're actually just bolting in glue code up the top to allow traversing between separately these different subtrees. But yeah, the feature you're looking for is schema stitching. There's 2 main options for it. You can either use Gramps, which Jason Lengdorf gave the keynote at GraphQL Summit last year on. So that takes a slightly different approach. That uses data connectors, but same outcome, different way to get there. Or schema stitching, which seems to be the predominant way of doing it though. But again, I wouldn't start there. Like, if you're going to say, start simple, get value out, see how you can operate it, and then if you're seeing that the rate at which you can change is being constrained by certain portions of the schema, then look to divide it up. But in the same way you wouldn't start building a microservices system on day one, right? You're going to have to understand, well, where would make sense to make logical splits within that schema, and then, so in other words, you can make an informed decision at some point in the future. Okay, we're out of time. Thank you so much for coming.